Okay, so the final example here would be graph the equation r equals 2 theta. So we can use this table and look at these equations to say, okay, well, it's going to look like a spiral. This is a good table to have around when you're graphing so you can know what it should look like before you even start. And the thing about Archimedes spirals is they get big pretty quick. So for this example, I'm saying each circle represents 2 instead of 1. And I went ahead and I found all the values. So let's start with 0. R equals 2 times 0, which is 0. And your thetas and radians always for Archimedes spirals. So R equals 2 times pi over 6, which is pi over 3. We can reduce this. And then we can find that value out, the numerical decimal value, which is 1.05. If we did pi over 4, R equals 2 times pi over 4. And we can reduce that to be pi over 2. And in decimal form, that is 1.57. And so on and so on and so on. So here I did all the values because we're not going to have a symmetry for your Archimedes spiral. So I did all the values with a 30 degree, 45 degree, 60 degree, or 90 degree angle between 0 and 2 pi. So when r is 0, when theta is 0, r is 0. That's in the center. When theta is pi over 6, we get 1.05. So that's just about 1, and that's at pi over 6. Oh, and each one of these is 2. So it's like half. And when theta is pi over 4, we get 1.57. It's a little higher. When theta is pi over 3, we get 2.09. When theta is pi over 2, we get 3.14 pi. When theta is 2 pi over 3, we get 4.19. When theta is 3 pi over 4, we get 4.71. When theta is 5 pi over 6, r is 5.23. When theta is pi, r is 6.28. When theta is 7 pi over 6, r is 7.33. When theta is 5 pi over 4, r is 7.85. When r is 4 pi over 3, r is 8.38. When theta is 3 pi over 2, r is 9.42. When theta is 5 pi over 3, r is 10.47. Here. When theta is 7 pi over 4, we get 11 for r. 11 over 6 pi for theta is 11.52 for r. And lastly, at 2 pi, we get 12.57 r. What we get is this nice spiral that's continuing to get bigger and bigger. And working on paper is a lot nicer than working on the computer. So I expect your graphs to go through all your points nicely, and you know what I'm doing here. And that's it. That's how you graph an Archimedes spiral. So whatever equation you get, we can instantly use this table to see what type of equation it is. We can use the symmetry equations to see what the symmetry is to help shorten the actual work we have to do within making our table. You're going to make a table, pick your theta values, solve for your R values, and then go ahead and graph and connect your graph. And that is the end of section 6.